back to back to back, right? So this is a special treat because these three speakers are truly distinguished in the sense that they publish a lot of research, they do a lot of active research, they're very famous in our field. Okay, so it's a really special privilege to have them all at the same time. Okay. Unfortunately, Dr. Lin is not feeling well, so he is resting over there, but he will try his best to deliver a lecture if possible. So let's see how it goes. Okay. Let me give you a brief introduction for each of these speakers so that I don't have to introduce them again. The first speaker is Dr. Jian Qin. Okay, Qin. And she's from Syracuse University, our sister iSchool in Syracuse, New York. And our student groups have visited Syracuse University a number of times over the last couple of years. So welcome to SKKU. And her topic sounds really interesting, and that's exactly what we need at this moment, because her talk is entitled Data Science and What It Means to Library Information Science. So many of the students who are sitting here are attending Library Information Science program. So it'll give us a really nice perspective on this topic. By the way, how many of you are from LIS department? Raise your hand. How many of you are not? Raise your hand. And which department you're from?
Economics.
Economics. Oh, okay, wonderful. Did I say it right?
Yes, yes.
Okay,
that's
right, thank you. And who else? I know we have to use the statistics department. Okay, right. The second speaker, Jian Qin, Dr. Lin, is from Drexel University, another high school in Philadelphia. And he actually, Sam and I, Professor O and I, visited Drexel last year, right? And we had the opportunity to meet with Dr. Lin last year, visit. His talk is entitled Knowledge Graph from Metadata to Information Visualization and Back, right? Our last speaker is Dr. Marcia Jiang. She's from Kent State University in Ohio. I had the privilege to have a job interview at Kent State University 17 years ago. I didn't get the job, by the way. Anyway, welcome to SKKU, and her talk is entitled Smart Data for Digital Humanities. So we'll have this talk, and then we'll probably, after we're finished with the second lecture, we'll take a 10-minute break, okay, in between. Okay, Dr. Qin? Okay, Qin.
Thank you, Dr. Shen. And thank you for Dr. Samuel for your invitation to give us this opportunity to exchange information about research, about our educational program, and it's a great honor to be here. Today, before I start my presentation, I can give you a little bit background about myself, so you can see where you come from and how you end up with this data science. That seems to have nothing to do with library information science. So to make you feel better, I had a a library science undergraduate degree, master in library information science, and PhD in library information science. So all the way, all my career, I have been doing work somehow has a lot to do with library and information science. So you should feel better that you are not the only one in this long road. So long story short, I've been in Syracuse for 16 years, and I started teaching information organization, and now because information organization is a field that has a lot to do with information technology. So over the time, cataloging evolved into metadata, and metadata is supported by many technologies that we have to keep learning in order to keep up with all this fast move in all directions. So XML, database, and RDF, now linked data and semantic web, and all these things just keep moving, and we just following the trend, and that's one direction. But metadata is a field that has that can be called a big data, using the fashion word. It's a field that has massive data, and how do we, in the traditional way, libraries has sitting on this massive data and thought, oh, okay, we just provide services for users to come to use it. But now with all this change, the data-intensive environment, data-driven science, data-driven policy-making, data-driven decision-making, and data anything. So now the whole landscape has changed, and that means my research field as well as teaching field has also evolved. So that's what in the last 7 or 8 years I've been doing e-science, research data management, metadata, and data mining, and anything related to data, but more on the management side, not so much about analytics. The data analytics is only recently. So even though I do research in data analytics, but not so much, not as an expert in that field. So that's why my talk today has a flavor of library information science, and more in the sense that data science in the dimension of management, curation, and discovery, and organization, and analysis is more related to user requirements and those aspects, not so much about those large-scale data analytics. There's some, but the focus is there. So let me see. Good. So I want to make my talk straightforward. So I have 3 themes in this presentation. First is about what is data science. Although there are many versions, I would like to focus on the version that has most to do with our field. Second, what is data scientist? And that's also related to what we can do, and especially I know many of you are interested in data science, in doing in a career that that has something to do with data. And so if we can learn something think about what a data scientist is, that might be helpful. And then finally, I'll give you some examples about the areas that in library information science that could have, that could benefit from the data science. So data science, actually, there are many versions, and this is the version that I like the most. Jeff Stanton is our current interim dean, our school's interim dean, and he wrote a book called Introduction to Data Science back in 2012, and he has recently published the second edition, and his book is free to download in Apple Store. So he said, data science is an emerging area of work concerned with the collection, presentation, analysis, visualization, management, and preservation of large collections of information. So it seems like a very generic definition, but it covers a lot of fronts that's relevant to library information science. Okay, so I like this very much because it does, it does emphasize the strengths of library information science. And of course, other fields like data science, they think it's about telling a story, use the data to tell a story, and that's more or less the the commercial world, the corporate world. Thank you very much. So when we think about data science more carefully, we realize science is a systematic enterprise that builds and organizes knowledge in the form of testable explanations and predictions. So this is more, I think, has the science aspect of the data science. But when you talk about data science, this is the study about the generalizable extraction of knowledge from data. So, involves data and the statistics or the systematic study of the organization, properties, and analysis of data, and its role in inference. So what is emphasized here is that it's generalizable extraction. All right, so basically, if you think about data mining, and that's one major area in data science, and that's also relevant here. So, and if you look at the education landscape in US, you will find many departments, not just library information science, but statistics, computer science, even like earth science, bioinformatics, and almost every disciplinary field are creating data science programs. So data science, why it is so so many people are interested in data science, because it's a field that has many possibilities, and it's just like library information science. It's a meta science. It can be applied to any domain. So it's different. Well, it's different from, although it has some similarities with statistics, computer science, but it's different from these single disciplines. it is, data science that uses the raw material, the data part of the data science. Okay, so and also its analysis of data requires a lot of things: actions, integration, interpretation, and sense making that is increasingly derived through tools from computer science, linguistics, and so many other disciplines. And data are also increasingly generated by computer and for computer consumption. So data is not just digital data generated and then human data scientists use the data, use tools to analyze, but in many ways data are generated by computer and for computer. But of course, when it's generated for computer, the design and the end ultimate goal is to serve for the humans, right? So the scalability in decision making has become possible because of big data that serves as the raw material for the creation of knowledge. And scalability is one big factor in data science that's in the past without without massive data that has been impossible. But now it's possible. And so if you think about the Google analytics, and you probably have heard, excuse me, in the data science articles and professional conferences, they think, okay, decision making doesn't have to be precise. It's rough estimation, because in the past we have to draw a sample because we don't have the tool to deal with massive data. But now we have the tool to actually get the whole population. Why don't we just do the whole do the analytics for the whole data? So that's what scalability make this large-scale data-driven policy-making, decision-making possible. So besides all that definition about data science, the data science, if you want to have a good overview, like very high-level view, it's possible to look at data science from two perspectives. One is the methodology, and the other one is domain application. So methodology, it's you can see this computer science, statistics, visualization. Our Professor Lin is the expert in that field. And geospatial data analysis and data collection and digitization, interdisciplinary effort. So these are all methodology related in terms of data science. And so if you look at these terms, it's not difficult to see that statistics itself is a discipline, and computer science itself is a discipline. So basically it says the methodology part actually involves the integration, integrated application of all kinds of methods to from different fields. So that's what you probably have heard, that a data scientist is a statistician, a programmer, a mathematician, and analyst. So they are and a communicator. So it's many different roles involved in this, because as a data scientist, you need to be skillful in using these methodology. But this methodology can be applied to many domains. So that's why the data science right now becomes so popular, because it creates a lot of possibilities and a lot of opportunities for doing things that in the past that have not been easily done. So that's about data science. And let's look at what is a data scientist. And there are many articles and discussions about what is, what a data scientist I expected to have in terms of the skills. And math skills, and these four are the, I think it's a simplified discussion about what is a data scientist. So math skill, statistics, and linear algebra, that's basic things you need to have in order to do some simple analysis. And the computer skills, you need to write program, be able to write code, and to hack something, right? So infrastructure design, and those are the like database, design the database or design some data models, and so those are the computing skills. And able to communicate, and this is especially important, and I have examples later to demonstrate why this is so important. And ask the right questions. So the ability to ask the right question involves domain knowledge and expertise, and coupled with a keen ability to see the problem, see the available data, and then match up the two. So it's not, it's the skill that cannot be learned overnight. It has to be learned through experience, through practice. So I'm going to tell you a few stories, a couple of stories that from my own experience. So back in 2012, when I was teaching the data management course, and I have my students going out to talk to faculty, and to the students will divide it in 2 or 3 people group, and going to interview faculty to learn about their data management needs, and trying to develop some solutions for their data management needs. So one group went to faculty who was doing the global migration study. And this global migration study investigates how migrants, refugees and so on, move, in different stages. For example, if like right now, Syria, refugees move from, move out of their own country, go across, some Europe, Austria, and then enter into Germany, and some even went further north, go to Sweden. And so those are and along the way there are refugee camps, detention centers, and asylums, and etc. So this group went to interview the refugees, and coupled with like lawyers working with refugees and etc. And they generate data like interview audio recordings, photographs and articles, newspaper clippings, and written notes. So in the first place, when these researchers, they just had a problem, because it's a very simple problem. They don't know how to use Atlas TI. I don't know anyone used Atlas TI. It's a qualitative data analysis tool, and they don't know how to use it. So they can't, because we are helping faculty with the data data analysis tools, and study their data management problem. So they come to us, and our students went to interview them. And first they trying to identify what the problem exactly is. But from the initial how to use Atlas TI, which is a tool, data analysis tool, and which, what data do you have, and how do you collect them, and how do you deal with, what do you do with the data So after step-by-step interview and this interview back and forth communication, they finally identify the bottleneck problem is not how to use the Atlas TI tool, but instead is the difficulty in finding the data by person, interview, and the related artifacts, and in transforming the data into the analysis software, how to load the data into Atlas TI. So, this is a story very interesting because initially the problem, the data problem, seems to be a tool software problem, but it turned out it's the data the data finding problem, data use problem. So the student identified this problem. They designed a database, standalone database with interactive software interface, and for them to take to their field. When they collect the data, they use the tool so they can organize the data from at the time when the data was collected. So that was a good story about how to identify the major problem and design the solution. The next problem is similar, but it's in a different field. This field is thermochronological and chronology and tectonics. And this is basically a field that they go into different places in the world and to collect the rocks from the surface of the earth, from the bottom of the ocean, and sometimes they drill down to to the earth and to get the sample rock to study the time the rock was formed, and in order to determine the age of the rock, and so they can tell what happened during that time. So when they collected the data, they have these are the rock samples, and the rock samples may be rock, and then they slice it into very thin slices, then put under the microscope and look at them. They appear to have some images, and these images are captured and stored, annotated and stored in their system. And they also grind those rocks into the grains, so they can use the lab instrument to test the mineral formulation in the what's contained in the rock. And then they record the data, annotate the images, and annotate the methods used to generate these data. And these data are put into Excel files. And the Excel files is not just, so you can imagine there are hundreds and even thousands of Excel files. And this has the problem because they can't remember when they generated some data file and they put the result in which file and who has it, because the research group involves graduate students, multiple faculty members, and each faculty member has a couple of graduate students. So when you have a large group like this, and when you generate the data files in a fast pace, so they have, but on the other hand, the data the data are required to be, the data sets they generate should be verified, organized, formatted, aggregated, categorized, linked, searchable, reusable. That's desired, but this would not be able to help them to get to that point. So there's the bottleneck problem. So in the end, my group, the student group designed another, designed a data model, and so they can use this data model to build some data repository tools to support their data management. Another story is the, let's see, Well, this is another one. I think maybe I don't have enough time to talk too much about this, but this is actually from my research project. So we used the metadata from a large data repository called the Jian Qin. It's the international data repository storing the DNA, RNA sequence. And because there are metadata describing these data sets, and we use these metadata as the data source to study collaboration networks, to study how scientific collaboration evolved over the last 20 years or so. So, but because this is large-scale data mining, and there are many problems involved with the data. You need to clean the data, disambiguate the author name, and a lot of problems. So this is the another example about using a new using the metadata source as a data source for data science analysis. So analysis of data problems is an analysis of domain data. So it's not just analyze that problem. It actually involves analysis of domain data requirements and workflows that will lead to the development of solutions. So these requirement analysis, workflow analysis, data modeling, data transformation need analysis, data provenance needs analysis, and all these are, in the domain of analysis of domain data. So this involves, you can't just go out to talk to scientists. You must have some basic knowledge. If you for example, when you talk to scientists, even though you are not in that field, but you should do your homework, learn enough in order to make the conversation going, to make a meaningful conversation in this process. And that's part of the communication skill, okay? So the skills required to perform analysis of domain data problems involves, so that is what I mentioned from last slide. But here, for the, you can see that interview skills, analysis and generalization skills, and that's the communication part, and the ability to capture components and the sequences in workflows, ability to translate domain analysis into models, ability to envision the data model within the larger system architecture. So when you are talking to, say you're working in a company, you are a data scientist, you have a project that helping your client to solve some data problem. And the first thing you need to do is to interview your client, understand their needs, understand their requirements. And so in order to be able to do an effective job in that process, it's important that you have these skills. In this sense, the communication skills and the technical ability translated into some sensitiveness during the process that you can immediately translate, what you hear, what you see, into some meaningful, data science stuff. That's what I can say. Modeling means you take what you learned from your client and build into some model. And this is the workflow model that we developed from talking to astrophysicists, are trying to understand their data needs, trying to understand their research life cycle, understanding the research life cycle, and the workflows, trying to understand every step, and also the relationships between the steps and the data flows, which goes in, what goes into a research life cycle, and what goes out at the end. And during the process, what's the entities, attributes, and the relationships, and also research, trying to understand researchers' practices and the habits in documenting and managing the data. So that's what we have been doing. We spent a lot of hours just to get this this model right. So we talked to the astrophysicists, and once we have this model, we will take this model back to them to get their validation, because this model will be important for us to develop the metadata model for their data management. So that's one example. Another example is asking the right question in mining metadata. That's from the Jian data mining project. The metadata, we know metadata describes data sets, and in this case, it described the big data. That's because it has 100. Jian at the time of 2013, when we collected the data, it contains 136 million DNA sequence data sets. So that means it's a huge data collection, and we need to study the collaboration network and scholarly communication patterns, research frontiers and the trends, and knowledge transfer, pay ratio and pace, and the research impact assessment. So these are the things that we are looking for, but how do we study them, and what's the right question to ask based on the data? And that's a big challenge in doing this research. So that is a brief introduction about the data science, data scientist. And now I'm going to talk a little bit about what areas of library work can benefit from data science. I'll go faster. So talking about data services and data-driven services in libraries or any information centers, similar organizations, we divide data services into two big parts. One is using the external data to provide data services that support research, learning, and policy making. So that's use data, not the library internal data, but data from out anywhere. And then the other part is data-driven services that support library planning, management, and the evaluation that uses, for example, circulation data, the collection data, and the library services statistics, and that can be used to conduct, to provide data-driven services. For example, just last week, OCLC released a report, published a report about a university in Australia use libraries' internal data to study, to help library, I forgot what is exactly about, but that use the collection data to help them to weed and to weed their collection and doing some meaningful management work for their library services. So data services, that's look at the data which used to provide the service, but regardless which area, which data source you use, but usually when you talk about data services, it includes data curation, data discovery, data consulting, data literacy training, data mining, data collection, data integration. So I will give you a little bit about each of this. So before I talk about this, and I want to cite one article that's about, the title, the citation is down there. It says data-driven, creating a data culture. And in that article, I think this question is very interesting. The question asked is, it's your company, because this is for the company, for companies. So I changed the subject, saying, is your library or company, research center, any organization, a data-driven organization? So I think this question is interesting to consider in this data-driven environment. So in the commercial world, there are consumer internet companies like Google, Amazon, Facebook, and there are also brick-and-mortar companies like Walmart, UPS, etc. So data-driven organization acquires processes and leverage data in a timely fashion to create efficiencies, iterate on and develop new products, and navigate the competitive landscape. I think that this can also applies to library world. It's the same, So data curation, the first one in this bunch, data curation, I think this has been a subject for quite a while, and has several iSchools in the US has developed courses on data curation. So it's basically focused on research data curation and creating data repositories, and the management involves the whole data life cycle. Okay, so I'm not going to give you a detailed discussion, but just quickly go through it. Data collection. Building data collections, libraries can build data collections through institutional repositories, community repositories, and also develop tools for researchers to submit, manage, preserve, and discover data. So, and also can develop data collections that is specialized, analysis ready, reusable, and actionable. So these are, each of these we can have, like, I can talk for days if you want, but I'm just bringing these up just as some talking points. And for library service planning, decision making, and evaluation, and these developed data collections can be for library services, and it can also support policy making for support for research and learning. So this is the data collection. And we used to say, before the internet era, or even during the internet era, we used to say content is king. And I think this is still true in the data-driven environment. So if you have data collections, data repositories, and this is a valuable asset, and you have to, building the data collections, develop the data collections, and if they can have these characteristics, that would be great. Data discovery, I think that's our library's strength. We have this tradition, but except that the object that we are trying to discover is the data sets, data collections. And I think for this, there are also many discussions. And the data sources can be for various purposes. So it can be open, reusable. And for census data, and for government data, disciplinary research data. So there are many different types of data, and all these data, the data discovery, and I think in many U.S. Academic libraries now, the data librarians, one of the data librarians' duties is to, assist users, assist faculty and the students to discover data sources that they need to use for research and learning purpose. Data consulting, and I have a lot of stories to tell in this, but I can tell you data consulting can be a fee-based service inside the library, and which University of Virginia back in 2012 had a two-people team that started this data consulting service. And last time I checked, that's earlier this year, it has evolved into a 12-people organizational unit called Research Data Services. And so from 2 people evolved into 12 people in about 3 years' time. So you can see this is a fast expanding field, one of the services types that libraries are doing. And data mining, and that is another field that libraries can also make contribution. You can use internal data, and you can also use external data and for different purposes. And data integration, that's the combination of technical and business processes used to combine data from disparate sources into meaningful and valuable information. So this process involves a lot of work, cleaning, processing, and delivering, and so this is an example of data integration. So we know buying a house is, is just a normal consumer activity. And when we buy a house, we want to know about the house itself, and also we want to know about the neighborhoods, the school ranking, and the crime rate, and the demographics. So all these data can be brought together in one place. So when you look at the housing information, whether you make a decision to buy or not to buy, often people would like to know other information, especially for young people. They are going to raise a family. They will, care about the crime rate and the school rankings. And so, and if you look at the query, and this is kind of query, and what kind of data and what kind of data model, data structure will be able to support this kind of query, and where the data will come from, how are you going to integrate them in order to be able to answer this kind of query. And that is, some very interesting data integration question. And this is another one. This is the research data integration. In US, there's an organization called CDC, Center for Disease Control. They do surveys, they do surveillance of diseases, and this is about diabetes. So basically what they use the collected data to provide this geographic visualization of data. And you can download the data, and I also call this as a data product, and because they are interactable interactions, the users can interact with the data, and so you don't have to know survey methodology or statistics in order to learn about diabetes. So to summarize, data science is not a new discipline, but rather it's a new way of utilizing data methods and tools to ask the right questions in solving problems. And practicing data science requires strong skills in math, computing, interpersonal communication, and asking the right questions. And libraries are at the strategic position in practicing data science. How to leverage this position relies on the vision, your vision, and courage of risk-taking, and knowledge of data science and the related topics, careful planning, and the collaboration. And thank you.
Can you believe Dr. Jian Qin arrived in Korea 18 hours ago? I expected she was very sleepy, but yeah, a little bit over time. She tried to inform many things to students. I really appreciate it. And any other questions about data science and related to library and information science? Yes. Anji?
Do you use query when you import the data? Then can you tell me more about specific program you use for queries?
Query which data? You mean in data discovery or in?
Anji, you can use the microphone in front of you.
Okay. So query what data? Which slide? This one?
Yeah.
Oh, this is just a scenario. Use a scenario. So say I go to a realtor's website. I would like to search for a house, and you can search for, if I choose to search, a house based on these conditions. And this, when you design the system, usually in system design, you use scenarios to provide typical situations in which information might be used. So then you design your system to meet this kind of requirements. So it's like, okay, under 250K, that means we need to have 250K translate into price of the house, right? And that price is a search option. And then at least two bathrooms, number of bathrooms. So based on these scenarios, you can translate these the query into conditions that a system must be able to meet in order to answer users' question. But when you search, when you ask for which school is, what is the ranking of this school? But if you are buying the house, the realtor system most likely don't have the school ranking data, and the data has to come from, say, the state education board. But how do you make the data integrated into the housing website? And that's, and this data, it will be constantly be updated. And when you do search, you can't manually, do it. You have to have some mechanism to automatically ingest the data, continuing to provide the updated information. That's the data integration challenge.
Any other question? No? Okay.
The last question slide, because libraries are can you go to the last page of the presentation? Yeah, youth group, the libraries are at a strategic position in practicing data science. In what kind of specific point that you think library as an institution has a correlation with the data science? I mean, educating users in libraries, or?
It's all around because if you want to provide data services, and I'm just talking from the experience of the last few years that academic libraries provide studying data services. In the first place, they had a difficulty because they don't have enough people who have data science background. They don't know enough about data science. And second, users don't know about data. You don't have enough data skills as well. So you need to have staff. You need to train the users who have, with data literacy, and you need to provide services to support them. So it's all around, not just which one is in particular, but all these need to be coordinated together, to work together to make your, the library services to be up another level.